So I hope it all was a good weekend for everybody. I didn't have much of a weekend. I was here at 10 o'clock in the morning on Saturday until 1 o'clock in the morning Sunday. Not once leaving campus. You tell me where the weekend is.
I wasn't there for you.
We have 2 weeks.
You did 6, right? He goes on the bus and he sits there and so I'm like,
Like Monday, Tuesday, Wednesday, Thursday, Friday. All right. I need. Excuse me. Oh, thank you. I need 5D and 5E out on your desk, please. Those would have been assigned. So have those out on your desk. Make sure your name is on them. We'll start passing the stapler around so you can take care of that.
I'm so proud of myself. I didn't find
Start over here.
That's what I did.
All right, 5D, 5E out. Do you have enough time to get it out?
I was just like, wow.
Do you have enough time?
Never.
All right, 5D and 5E.
I did not get 5D.
Go on an E, so you got a D. That's a B. Oh, buddy. Yours. We'll get it. I want to get these. Where's that 5D?
Don't worry, I'm telling you then tomorrow. Only do. Check all pages.
That's 5C.
5C. That is an abscess. Well, we've started it, and I told you guys to turn it so I didn't have to deal with grading over the weekend. Yeah. You did. I have yours. It's in the grade ball. Alright, my phone's over yonder. Make sure yours is over there as I come around, please.
Who did a hotel with?
That never won. Oh, yeah.
What?
Did you wait? All right. Here you go, Hannah. First one in. All right, so taking a look at 5D, I know that we went over quite a bit of it the other day, but was there any extra help you needed on 5D? Yeah. I don't know what you're talking about.
On 5D.
Oh, number 5.
It's like a graphing problem.
Oh, okay. Let's take a look. I thought you were meaning worksheet 5. I'm like, it's the whole thing. All right. That one? Okay, sketch graph. Use whatever process. Okay.
Yes.
You know where I'm moving you? That back
Yes,
corner.
yes, yes,
Now.
yes.
Inside or outside? All right. So we want to figure out our vertex. We love you. But your friends annoy you too much.
So sad.
Agree so far?
Yeah.
Fiona, if he talks, side of his head, side of his head, use your pencil, just jab him. All right. How do I find the y component? Plug it in. 25 minus 50 plus 19. A little too much talking. I've moved one person. That doesn't mean everyone else is exempt. All right, so that's negative 25. So that's going to give me a negative 6. Pattern graph going up, so right one up 1, left one up 1, right one up 3, left one up 3, dotted. 0, 0 is outside of it, yes?
Yeah.
So 0 is less than 19, true? So shade outside. There we go. What else from 5D would you like to see? Yeah?
18.
18. So it's 2 parabolas, yes? One's dotted, one's solid. All right, so this one doesn't have a b value, so 0, 4. And then it's going to go right one down 1, left one down 1, right one down 3, left one down 3. 0, 0 is definitely inside of it. Agreed? Yeah. All right, so then let's do this one. So I get negative b over 2a. So that's negative 1. So that's going to give you 1 minus 2 plus 1, which is 0. So negative 1 comma 0. Which is right there, and this one opens up. So right one up 1, left one up 1. Solid. So 0, 0 is inside the green, outside the blue. Let's see if 0, 0 will work for us as a test point. So there's our test point right there. Inside the green, outside the blue. So I get 0 is less than 4. It's true. So it's going to stay inside the green. Then I get 0 is greater than or equal to 1. Sorry, I'm interrupted. Which is false. So I'm going to shade inside the green, outside the blue, or inside the green, and inside the blue. The reason it's inside the blue is because this point would have been outside of the blue. Agreed? So this is my region. All right, go to 5E. Make sure your names are on 5D. Pass that on forward as well, please. Make sure your names are on 5D. Pass that one forward. Let's take a look at 5E. Please. 5E. Number 2? Okay. All right, describe the transformations, identify the vertex as an ordered pair, identify the x-intercept as ordered pairs. If there are no real intercepts, state none. Identify the y-intercept. Okay. So it's going to shift right 1, up 2. Our vertex is going to be 1, 2. And then I forgot what else it was asking. Identify the vertex transformations. Identify the X-intercepts. Is it out? No, you're good. Good, sweet, thank you. So we're going to identify the X-intercepts. So I'm going to plug 0 in. So I get 1/2 x minus 1 quantity squared plus 2. All right, subtract 2 from both sides. Multiply both sides by 2. I could stop there. What can you tell me right now about the X-intercepts? Yeah, if I do the square root, what happens here? What's the square root of -4?
No solution.
It's actually plus or minus 2i, but we're not dealing with complex numbers right now. That means it will not cross the x-axis. Okay? Because the square root of a negative isn't going to exist in the real numbers. And then where does it cross the y-intercept? Find the y-intercept. Plug 0 in for x. So plug 0 in here. -1 squared is 1. Half of 1 is half. Half added to 2 is 2.5. So again, you plug 0 in here. Square that, so that becomes 1/2 times 1 plus 2. So half times 1 is half, plus 2 is 1/2. Or, number 4, y equals x plus 1 quantity squared. Graph the quadratic, use any method, define most efficient, label the vertex and the axis of symmetry. Okay. My vertex on this one is going to be -1, 0. My pattern graph is right 1 up 1, left 1 up 1. Looks like this. My axis of symmetry is right here, so I can label that to say that it's x equals -1. That's it. Anything else? 15. Ooh. Who said ooh? I hadn't heard yet, so I didn't know if she's sleeping or not. 15, and then I'll get to yours. Ooh.
Yeah, I say that I understand, but I really just don't.
Okay, graph each quadratic using the method you find most efficient. Label the vertex and axis symmetry. Okay. So I'm going to go -b over 2a on this one. So I get x equals -24, -24 over 2 times -4. So that's my axis of symmetry. If I take -3 and plug it in, plug -3 in there, that gives me 9. So that's going to be -36. Minus 72 plus 36. Is that right? Oh, wait. Hang on, -3, that's a positive. I'm sorry. So, yeah, because I'm plugging a negative in. That's a minus 36. Okay, so -36, -36, that's a minus right there. That's -72, added to 72 is just 0. So I get -3, 0. And then I got right 1 down 4, left 1 down 4. There it is. Olivia, ooh.
Oh. Okay.
Oh.
I have a but
Pick one first.
22.
2, 2. All right. 2, 2. All right, number 22, the top one. So we want to shade, graph and shade. So this one, we're going to have a dotted, and it goes -3, -2. And if I pattern graph right one up one, left one up one, right one, 3. So dotted parabola, agree? All right, and then this one we'll do as a green, a solid line. So I get x equals -b over 2a. That's going to give me -1. So if I take -1 and plug it in here, that gives me a 1 plus 2 plus 1. So that's -1 comma 4. So I'm going to go right one, up one, left one, up one. So that's what that one looks like. I can pick 0, 0. 0, 0 is outside both parabolas. If I had a true on both of those, it means I shade everything outside. So if I take 0, 0, plug it into this one, I'm going to get 0 is greater than -2. That's true, so that means I shade outside the blue. Then if I take 0, 0, plug it into this one, I'm going to get 0, yeah.
Isn't it supposed to be positive?
Yeah, it's positive 1. You
Where are we at?
the
Green or
negative
blue?
2, green. The negative
Green.
2, it's positive 1.
It's positive 1. Sweet. Positive 1. Positive 1 minus 2. That's 0. Oh, biscuits and gravy. So that's where our graph is now. And we'll erase the screen one. Am I right now? 1, 1 still works as a test point, and I have this. 0 is greater than 1, so that's false. So I'm going to shade outside the blue, inside the black, which is here. Done. Okay, make sure that one's stapled. Name on it. Pass it forward, please.
Can we do 21?
Nope. Come see me.
Oh God, I still, okay, this is not. You're gonna go look for lunch. That's not me. I don't, coffee's right. Yeah, that coffee. Coffee's not espresso. Oh, I can't write this.
I'll bring 5 and 5.
Yeah,
Okay.
I wouldn't, but I would.
Works for me.
Like I do every day. And it's real bad. Yeah, no, I drink way too much coffee. I need to like calm it down a little bit. Same. What more could there be in this chapter?
All right.
It like doesn't have to do with the rest of it. I don't even understand. This is literally just like the distributive property of this. I just, it doesn't make sense. I know how to graph distributive properties. I know I can graph the standard form, but nothing else. Oh no, it's the first one. Very.
All right. So this will be pretty quick until we get to the actual breaking it back down. Factoring.
Hey.
Yeah, I should have notes out. Did notes not come back yet?
Factoring is actually like pretty chill.
All right. Ready? So steps, distribute, make sure you distribute the negative, and then collect like terms. Distribute, 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 so I get 3 minus 2x minus 10 minus 12 plus 3x. Notice I distributed a negative over the parentheses, so both sets changed in there.
Okay,
Waiting.
I understand.
Now I have some like terms.
This is way too
I,
That's lattice.
don't worry, no, that's not lattice.
That is lattice.
No,
That is.
that's barfing your mouth a little bit, but we're not gonna. Don't worry, I'm gonna do one of those. Yeah.
Okay.
All right. So 3 minus 10, -7. -7 minus 12, -19. Agree? And then combine here, here. So I get plus x, and you can have your answer is 18 minus x or 19 minus x. Your choice, which way? Gentlemen over in the corner, you're talking too much. I've already moved one. I can move others. Don't worry. We can start moving other people. We good? Move on? All right. All right, so you need to put your answers in standard form. So ax squared plus, so the exponents of the variable come in descending order. So your x squared, then your x, then your constant. Monomial means you have one term. Binomial, there's two terms. So when a term is separated by an addition or subtraction sign, and a trinomial is three terms. And they build from there, but let's not worry about the Latin roots of this. Did you have that on your paper?
Yeah.
I couldn't remember if we covered stuff up or not. So a lot of this is pretty much review. So this is just FOIL, correct?
Yes.
Now Common Core said, no, it's called double distribute. Okay? No, it's FOIL. First, x squared, outside, negative 2x, inside, plus 5x, minus 10, combine like terms. So what cracks me up about the Common Core is when we were teaching people how to FOIL, we put a man on the moon, we developed cell phones, we developed electric cars, but then Common Core comes along going, we're falling behind the times. Okay? Don't think so. So does everyone agree this would be x squared plus 8x plus 3x plus 24?
Yes.
Combine like terms. Welcome to Algebra 1. So we're going to be working on going backwards, but we're going to have to go faster backwards than we have in the past. So by factoring. So I have a way of showing factoring that works, but as you advance further and further in math, you have to have foiling down. It has to be something like, you know, can you go 3 times 5? Yeah, it's 15. It has to become quick. Okay, if it doesn't, you're going to be really dragging behind in calculus, and that's the part. The hardest part about calculus is the algebra. I promise you that. And it's just because people get so hung up on it, going, I don't really need to know this. Then they're in calculus because they were able to pass algebra at some point. Then they're like, well, I suck at algebra. Well, if you suck at algebra, calculus is not good. But calculus, the concepts are good. All right, all this is this.
That just looks kind of gross.
It's just unnecessary.
That's all it is. Combine your like terms. That's all this is some fancy thing. I'm not a real big fan of it, so it's up to you if you want to use it. Okay? So it's just showing that you can multiply term to term. We good?
Yeah.
Move on?
Yep.
All right. Agree? Agree? What am I starting to do in my head? Yeah, the middle terms, the O and the I. Okay, 3x and 3x is 3x and 2x times 9 is 18x. So 3x plus 18x gives me 21x. Then I have, I can't do it in my head anymore. Combine like terms. And then let's see if I can do this one. 10x squared minus 2x minus 23x plus 4. Okay, so again, the easy part on binomials is going forward, multiplying it out, doing your double distribute, doing your FOIL, doing whatever way makes legitimate sense with you. Cool?
This is easy right now, but I know it's gonna trick me.
Well, the thing is, we're going to go from the red back to the black. Don't worry, I'll get you through it. Okay, again,
It's easy now.
that okay?
Yeah.
You'd rather do this than what? 36. So
Why are the parabolas in the same way? Can we just do this? Let's just take
it's
the
squared.
parabola, please. Oh,
so it's a quadratic,
okay.
right? Yeah, these are all quadratics that we just had broken down into binomials. We multiply them back together. You can find your vertex by going negative b over 2a on these. These are in intercept form, so you could find like number 6. It crosses the x-axis at 3 and negative 9. Find halfway in between for your axis of symmetry. Plug in to get your y component. We good?
Yeah.
So yes, these are parabolas, and we will continue with them. All right. So then, what do we have here? All right. This would be x plus 5, x plus 5. So what you do here is this.
X squared plus 10x plus
And this one. And then okay, how did I do those so quickly? Well, it's the first term squared, the last term squared, and then you multiply the two terms together. So you get, like on number 9, you get 5x and double it. Next one you get negative 14x, double it. Next one you get that should be 12. You get a 6x, double it. Next one you get a negative that should be a negative 20. I got cocky. So the pattern on these, okay, if you have x plus y quantity squared, it's going to be x squared, y squared, plus 2xy. That's your pattern, where I'm using x and y as your variables. So if you had x plus y times x plus y, if you multiply it out, double distribute, FOIL, whatever you want to use, it comes down to that. That's the pattern. Is that okay? Can we move on?
Yeah.
Okay, we're good? Olivia, you're good? You're just leaving us? As soon as she gets out, I'm going to teach you the easiest way to factor, and she's going to come back and she's going to be really mad.
I
Okay.
know how to
All right. These are pretty easy because these are called the difference of two squares when you multiply them out. Being that the two binomials are offset by one sign, they're the exact same binomials. The middle terms cancel out. So if you recognize it, you have the same binomial repeated in the middle, and you just offset by one sign. You forget your O and your I, because if you were to multiply on number 16, you get 10x, positive 10x, added to negative 10x. They're gone. They cancel out. But again, recognizing the pattern, trying to get through it quicker, will allow you not to get hung up, especially in further along math classes. We A-okay?
Yep.
Can I move on?
Yeah.
All right. Now we want to reverse it. Okay? So some of them you can see a pattern pretty quickly. So what are the factors of 12, both being positive, that would add to 7?
X plus 3 and x plus 4.
There you go, x plus 3 and x plus 4. Okay? If you can see those patterns on the simple ones quickly, that's awesome. Some of you might not see it. Some of you might need to know this. Okay, I'm going to take my first and last term, multiply them together, so I get 12. The factors of 12 are 1 and 6, 3 are 2 and 6, 3 and 4, and 1 and 12. The ones that add are this, so you can go x squared plus 3x plus 4x. You could have 3x and 4x reversed if you wanted to. It's still going to give you the same. Look at these first two terms. Factor 4 out of these. And then you have x plus 3, check. X plus 4, check. Done. So this is the grouping method of factoring. Some of you might have heard something called the dream method at some point. Some of you might have done the diamond method. Some of you might have done the box method. Some of you might have just looked at your neighbor's paper going, oh. All right, second one. You agree that it's x minus 6, x minus 1. I could have had x minus 1 and x minus 6, but how did I get that so quickly? Well, I realized 6, in order to get to it, it's either positive 6 and positive 6 or negative 6 times negative 6. It has to be negative in this case because my center term, when added together, has to give me negative 7. You want to take a shot at number 19?
7, 3.
X plus 7, x plus 3. Sweet. About number 20?
Negative 3, negative 2.
Oh, someone. Who was your math teacher for algebra?
Richardson?
Yes, that's why.
That's a good teacher.
He's the best. Sorry you got left with this sap of me.
You're not that bad.
Not that bad. Oh, thanks. All right. We're not trying to find the vertex. We're just factoring. All right. What can we factor this down to? X and x, agreed? 9 and 2? Negative 9, positive 2. Love it. Agree? Let's try this one. X and x. What are the factors of 12? One being positive, one being negative, that add up to negative 1. Which one's negative?
Negative 4 and positive 3.
There you go. That's all it is. This is good math.
All math is good math. Except proof, because no one likes proof.
All right. This is the difference of two squares. X plus 6, x minus 6.
X plus 11,
X plus and minus 11. Agree? So again, the factoring, if you see the patterns, those are both called the difference of two squares because the first is a perfect square because x times x is x squared. 6 times 6 is a perfect square, separated by subtraction sign. Again, we just work these, multiply them together. Okay? So how do you factor a binomial? So look for a common factors. First thing, difference of two squares. Second thing. Were those already written on your paper?
Yeah.
Okay, good. I can move on. All right. Number 25. We have a common factor on both of them that we can factor out first. What is it?
5.
And?
X.
5 and x. If I factor a 5 and an x out, I'm left with x here. If I factor a 5 and an x, that's factored. So this breaks down to a monomial times a binomial. If you redistribute the 5x, you get back to your answer. What's this?
7 and negative.
X plus 7, x minus 7. I'm concerned that a couple of you are talking a heck of a lot and you're not participating in it. Then you're just going to complain to me going, but I don't get any of this stuff. I'm going to let you clue in. Why don't you get any of this stuff? Because you're not paying attention, you're not playing class. It's kind of an easy concept. Okay? Difference of two squares. 25 does have the greatest common factor in it. Can I move on? All right. So the zeros of a function. Ooh, there's stuff to remove. Get rid of that. Wait. Where'd it go? Hey, stay. Uh-oh. Undo. Undo one more time. Undo. Who cares what? All right. I think that's everything. So the x-intercepts of a value for which the function value is 0 are also called the roots. So where it crosses the x-axis are called roots. Seem okay so far? So then the zeros and the roots are the same thing. So if you had y equals x plus 2 times x minus 5, if you set each binomial equal to 0, you'd find the roots being -2 and positive 5. So it's the opposite value. The multiplication property of 0 or zero product property. For all real numbers a and b, if a times b equals 0, then either one of them is equal to 0 or so either a or b is equal to 0. So if x plus 3 and 3x plus 2 equals 0, then x plus 3 equals 0 or 3x plus 2 equals 0. So that's just kind of a, if you have 0 times a quantity, 0 times a quantity is 0. May I move on?
Yeah.
Thank you. Got one person on. All right. So it goes back to a little easier. So I get x equals 5, x equals -9. What's the difference between when I just factor them versus solve them? What's the one thing added to the problem? Yeah. It's equal to 0. Thank you so much. All right. This one is going to factor to x minus 6, x plus 1. Set them equal to 0, so I get x equals 6, x equals -1. Agree?
Yes.
This one, I'm going to factor a 2y out of both. So that gives me y equals 0 as one term, and y equals -1/2 is the other term. How did I get that? Well, I set 2y plus 1 equal to 0, subtracted 1 divided by 2. And then what should I do on number 30 before I factor it? Negative equals 0, so subtract 10. Good. So that's going to break down to x plus 5, x minus 2. Those are equal to 0, so I get x equals -5, x equals +2. Did I do my math right?
Yes.
Yay! What time we out of here? Don't lie. 11? Oh, sweet. That was it? I went that quickly through it? Oh man, I thought we had pages left. Alright. Guys and girls, you have to do me this favor. You have to do me this favor. If you are not doing well with factoring looks like 11 through 22, 23 through 26, 27 through 35. If you're not doing well with factoring, you have to let me know. So our homework for tonight will be 5F. If you bring it back to class blank and you didn't try it, it's going to be pretty difficult. So that's what I have for you. You have the rest of the period to chill with yourselves or